Welcome everyone. This is the seventh lecture of our course, and in today's lecture, we will talk about how to handle tabulated data in Julia. Specifically, we will be looking at another package called dataframes.jl, and this package is packed up with loads of options which will help us in working with tabulated data. This will also help us plotting them, and we will see that this package and the plots.jl package everything is working in a perfect synergy. So before starting that, let me quickly revisit the first presentation that I showed and let me go over the topics that I have completed. Okay, so here we have looked at all the basics of programming stuff. We have looked at variables, data types, conditional statements, loops, functions. In the intermediate portion, we have looked at multiple dispatch. We have looked how to navigate the documentation. We have installed several packages and we will be installing many more packages in today's lecture. And we have also been introduced to many inbuilt functions. And we also have started studying data visualization. And in today's lecture, we will be doing this data analysis. And I will also touch up on some of the remaining topics of data visualization, such as animating plots and those kind of things. So from the next lecture onward, we will be looking at doing numerical computation using Julia. So we are slightly behind the track. I wanted to cover all of this stuff within 6 lectures, but it will uh, get completed with one more lecture. So in today's lecture, I will complete all these basics and intermediate stuffs. And till now, if you have any questions, I am again requesting you all to go through these lectures carefully and attentively and ask me any questions or doubts that you have. So you can email me directly or you can comment on the YouTube videos that I will be posting, or you can also use the course portal and create a discussion thread there. Okay. So with that out of the way, let us learn about data frames. So this is the package that we are going to use. This package provides a set of tools for working with tabular data in Julia. The design and functionality of this is similar to pandas. So those who are coming from Python and is familiar with data analysis in Python, they know that pandas is a very useful package in Python that one can use. So this package is very similar to Python, and it has also taken some inspirations from the R language. And what the package maintainers have done is that they have combined the good features of both of these packages and they are giving us the best of both the worlds. Okay. So whenever you are doing anything in Julia that is related to tabular data, you will see that always you will be coming back to this package. So this is a quick overview of the data frames.jl package, and it has so many techniques, so many functions that I couldn't possibly co- comment on all of these things in a 50-hour lecture. So what I will try to do today in the first section of this video is I will introduce you guys to some techniques on how to handle data, how to import and read and write data, and hopefully with those techniques in hand, you will be able to do more advanced stuff, but by navigating the documentation yourself. Okay. So this package is deeply associated with these other packages. So StackSkit, linear algebra, then for different machine learning packages, for plotting packages, and data wrangling packages. So everything is working in a perfect synergy as I was talking about. So that is a brief introduction. If you want to learn about this package more, you can go to this doc page and start with the getting started, right? We will do live coding. So let's start. So the first thing that you have to do is write using data frames that will tell our notebook to install this package. So let us wait a couple of moments for this package to get installed. So the first time, if you are doing this, it might take a bit more time. So I had this package already downloaded in my computer. So all the time that it took was for compiling all the necessary functions. We will be using some other packages. One is CSV, another is HTTP, and the last one is query. So these packages are also integrated with data frames. So CSV will help us read comma separated value files. So if you have some data, suppose you are doing some real world study or doing some experiment and you have gathered your data and you have saved it in a comma separated value file. So to load that data into data frames, we need this CSV package. HTTP will actually help us to visit several websites, and some websites will have data hosted on them. So you can download those data using this HTTP. And query package is actually needed to filter data that's being loaded from this data frame package. Okay, so let's wait for our notebook to complete everything. Okay, so it has completed. So now we will see how can we create a data frame. So you create a data frame using this data frame function and you pass your columns to it. So there are several ways. You can do it like this. And if you wait a couple of moments, you will see that this has created our data frame. So the first time you run this function, this will take up some time, but after the first time, this will be very fast. So Julia, as we discussed in the first video, Julia is a language which uses JIT compiler, just-in-time compiler. So whenever you are using a function for the first time, it will compile that function. Uh, Now, if you use it, you will see that this is very fast. And you can also see that it has loaded our data nicely in this tabular format. It also shows them in the notebook in a nicer way. And you can also hover over the headers and you can see the data types. So the first thing that I want to stress that when you are defining data like this, you have to play, you have to pay extra attention that all the data that you are, all the rows that you are passing has the same dimension. Otherwise, you will get a dimension mismatch error. So let me just comment this out that we need to pass the rows with same dimensions. Okay, let me enable this cell and let me give it some data for us to work with. Okay, so the first thing that you need to do after you have loaded your data. So here we have created our own data, but suppose we wanted to use someone else's data, okay? So, or some we wanted to use the data that has been stored in our PC. So the first thing that you need to do after you have loaded your data is to check that your data is loaded correctly. All the headers have been associated with proper data type and those kind of things. So in order to do that, you can use this first function and pass it the data frame, and it takes also a number, say 3, and this will show the first 3 rows of our data frame. So if we run it, you will see that the first 3 rows are getting printed. Okay. So it was 1, 2, 3, 7, 8, 9. You can see that it is printing correctly. Similarly, if you change this to 5, you will get the first 5 rows. We also have another function called last, and that, if you have guessed from the name, this will show the last 5 rows. And you can also see that the last 5 rows are 6, 7, 8, 9, 10, and those are shown here. Okay. So that's how we can check that our data is loaded correctly. So now we need to see how we can get individual rows and columns. Okay. So this is very intuitive. If you have understood how to index into array, you can also do this easily. So if you want to get the first 2 rows, you can do it like this. And if you want to get, say, the first column, you can do it like this. So you will see that the first 2 row and the first column have data 1 and 2, and that is being shown here. Similarly, if you want the second column, you can get 7, 8. If you want both the columns, then you can pass a colon that will indicate that we want to get all the columns. Okay. So here you can see we are just getting the first 2 rows and all the columns. Similarly, you can also do it like this, where you will be getting the first row, but sorry, the first column, but all the data that are stored. So this will be 1 to 10, and we see that this is 1 to 10. So this is standard array indexing that one can do. So you might be wondering what is different here. The different thing here is that in data frames, you can also intuitively call your data with the dot syntax. So suppose if our column name or header is A, we can get that column. This should be df1 dot A. We can get that column by addressing it with dot A. So you have to write the name of the data frame, then dot, then the name of the column. Similarly, you can use this to get the second column also. If you are unsure what all the column names are, you can just use the names function and pass it the data frame. Then it will return you a vector which will contain the name of all the columns. Okay. So now we can access all our data. So let us plot this. So we'll wait for a couple of seconds for the package to get installed. And we have seen about different backends in the last video. So in the last video, I mostly used GR backend. So in today's video, I will be using the other Profi backend. Okay. And let me also specify the size that I want my plots to be 400 by 300 pixel in dimension. So let us wait a few moments for all of these packages to get initialized and installed. Okay, everything seems fine. Let me run this block also. That will initialize the property backend. So this is suggesting us to restart the notebook. Let us do that so that everything works perfectly. Okay, I think it will still work regardless of this error message. So let us quickly check. We can do a dummy plot. Okay, you can see that it is working. So we wanted to plot the data that is stored in our data frame. So let us do that. Let me comment it out. And to plot from a data frame, you can just use this syntax to get the elements that are stored in the data frame. So df.a comma df.b. If you do it, you will get an error because our data frame name was df1, and you can see that you are getting a straight line as expected. We can change the series type with scatter, and we can also hide the legend so that the plot is clearly visible. So you can see this is plotting all our data. So 1728 up to 1016. Now, with data frames, you have another way of getting these columns, that is by using this colon syntax. Okay, you will see that this is equivalent to df1 dot a. Similarly, you can also do it like this. So the one thing common is that anytime you want to get a whole column that is stored in the data frame, you have to use the dot syntax, and then the column name can be specified using multiple methods. Okay. So why all of these things are implemented? Because if you have seen different kind of tabulated data, your column names can be containing spaces also. So if it had space, then this notation that we use will not work, but this one is going to work. So let me quickly show you the rename function, which will help us rename the column names of this data frame. So let us call it first call and second call. Now, there are two versions of this rename function. Okay, one is this one, which will return you a new data frame, and another one is with exclamation syntax. So this is again a design choice, but this is indicating that it will modify the object in place. That means when you do it, suppose we do it df2 and change the column names, you will see that this is showing you the changed data frame with different column names. But if you check df2, which earlier was this, you will see that it has modified the object itself. But here, if we also check df1, then you will see that here this is not modified. So again, remember this rename function will change the data frame, or any other functions which does not have this exclamation symbol as a suffix will change the data frame, work on it, modify the data, whatever it does, it will do, and it will give you a new data frame. But if you are using a function which has this exclamation suffix, then most likely it is gonna change the original data frame. So be aware of these kind of functions. These are necessary sometimes because you do not want to create multiple copies of your data in the memory. Sometimes your data is say too big, say it is a 10 gigabyte data. If you create a copy of it in the memory, then your RAM will take up 20 GB of space. Okay, so that's why these functions are implemented so that they can be worked on in place. So now that we understand that, let us see how we can address the columns of this DF2 data frame. Okay, so we can try this, but you will see that this will give you a syntax error. So what one has to do is you have to address the column like this. Okay, you can also do it like this. Similarly, you can get the second column like this. Okay, and if you want to plot it, you can just specify the columns like that and turn off the legend so that we can see the whole data, and you'll see that it is plotting everything. So that's how we can plot a data that is being stored in a tabulated format. We can access it using the data frames.js package that will give your data in this nice tabulated format, and you can also use the plots package to plot them. Now let us see how can we use some macros. So we have learned about macros in Julia. These are these keywords which starts with this @ symbol. So we have seen in Pluto, you have a at bind macro. Similarly, you have this switch macro and these things. We have also seen this at dot. Okay, so this plots package and data frames package, they have another related package which is called stats plot. And the idea of the package is that we will always be plotting from these data frame objects. So you can do it with the base plotting package, but if you are always working with these data frame objects, that package has some nice features which we can use to address this plotting problem where we don't have to specify the data frame dot syntax every time. Okay, so let us see. So this is the stats plot package, and you will see that this package is a drop-in replacement for the plots.jl package that contains many statistical recipes for concepts and types introduced in the Julia Stats organization. So this is helping us in plotting directly from data frame, and besides that, it also gives us these 2D histograms, then this box plot, dot plot, violin plot. This gives us the capability of doing these error bars. So these new kind of plots can be done with this package. So how can you use it? Let us use this stats plot package. Let me quickly check that the name is correct. This is stats plots. So this will download all the recipes. So let it give some moment to install the package. And it has loaded. Okay, let me minimize the status bar. Okay, so now when you are using this stats plot package, you can simply use this previous plot function and you will see that it is working as expected. But when you are working with data frame, you can also use this at the df macro to plot directly from the data frame. So how this works is you will write at the df, then name of the df variable, then within plot, you don't have to specify df dot column name. You can just pass the column name. Okay. So let us plot the first and second column. So our data is df.2 and we will do a scatter plot. So let us just do scatter. We can plot the first column and second column. We can also choose the color to be something subtle. Okay. So when you are using this df macro or any other macro that we're gonna use, we're gonna see how to use into this video. You have to be a bit careful when your table headers or the column names have space in it. The syntax of how to pass those column names which have space in it to different macros is not always the same. So we have to be a bit vigilant. You might get many error messages. So let us run this and see if we get anything wrong. And as we expected, we are getting error. You will see that this will also not work. So in this case, what you have to do is you have to specify it with this calls function. Now you will see that it will work or not. It will not work. And now you will see that it is working. So this is a very bizarre syntax. So you not only have to specify that you are choosing from columns, you also have to specify that you are trying to index them using symbol, and then you have to give the name of your column. Okay, so this will not work, of course, because this is defined in this macro, not elsewhere. So only war with at df macro. Okay, you can try this without the calls function, and you will see that this is not working. So when you're using this macro, you have to remember this syntax. You will see that when you are using this query package, then that is using another syntax. So the best thing is, although the data frame package has good support of this tabulated data, which can have space in its column name, the best practice is to remove those spaces. Okay, then you can easily address all your macros and easily call your data as you wish. Okay, so let me quickly check if we have a data frame where column names are not present with spaces. Yeah, so df1 is there. So here you can see the true usefulness of this df macro. You can just specify the data frame. Say we're going to be doing a bar plot. We will plot A and we'll plot B. Now we can specify the options for the plot function, and you will see this is working perfectly. Okay, so this is just a tip that if you want to avoid all of these bizarre syntax, the problem is not with typing mode. The problem is that it is not uniform across all the packages. So you have to remember different syntax for different packages. So to avoid all of those things, just make sure that your data is not having any space in its column names. Okay, and you can write a function which will automatically remove any spaces from the column names of your data. So I will show you that, and that is a very handy thing that you can do. So even if when you are using someone else's data, we will see some examples. Even if when you are using someone else's data which has spaces in its column name, you can use that technique to remove all the spaces, and then you have a clean data frame and you can work with all of the packages perfectly. So let us see that. So we know that we can use this function to rename the column names. We also know that the names function will give us the column names of a data frame. Okay, so let me show you another nice function which is called replace. And what this does is you can provide it with a mapping, say like this. Then it will see the first argument that you have passed, which is a string here and my name. And then this is the mapping. So it will check the first string and see whether it has this D, capital D character, then it will replace all of the characters by X. So just to show you another example, you will see that everything will be replaced by what you specify here in the mapping. You can give it an empty mapping and that will remove those characters. So we can use this replace function like this, and that will replace all the spaces in the string with nothing. Okay. So there is one space between the first name and surname here, and that will get removed. So remember this mapping. This is a space within double quotes, then equal and arrow symbol, which is signifying a mapping, then this simple quotes with nothing inside. Okay. That will remove the space. So you can use this function. So this replace function has many other use cases. You can look at them in the doc. I will not go over them. So the idea is to use this function and these three in synergy so that the spaces in the column names will get automatically removed. How can we do that? Let us see. So our df2 has this first column and second column with spaces. So we can check that this is working. We will see that this will return a copy. This is not with exclamation, so this will not modify it in place. So what we want here is to use the map function, and we want to use the replace function here in such a way that it modifies the names that we'll get from this df2 data frame. So what will be the output of names df2? This will be the first column and second column. So when we do this mapping, then this map will work on each element of this array. Okay, we have seen all of this in action when we were discussing functions and in the last video also, so I will not go over them in detail much. So you can write the function here. So the function will take one argument, say x, and it will be mapped to replace function, which will take that argument, and the mapping will be with this. So if we run this, it will give you an error. Let me quickly see what the error is. Okay. So I used the variable x here, but here I have specified underscore. So now if you change it and run it, you will see that the spaces from the column names have been removed. So this is a very useful technique. Remember this. Okay. Now we can just use the rename exclamation function, which will modify the data frame in place. And we can check that the column names have been modified. And here what we can do is, let me quickly copy this code. Okay, we don't have to specify all these things. We can just write first column, second column as a symbol. Okay, this has to be colon like this. symbol, and I have a extra parenthesis here also. So if you type it correctly, it will work. I am making a lot of typos today. Okay, so you can see that this is working. So that concludes the basic section of how you can use data frames and the plotting package. Okay, so now that we have seen the basic stuff, let us see how we can use data that has been stored and we will download it from the internet. So if I just get out of the full screen mode, you will see if you search in Google with this search string, GitHub datasets CSV, you will have different kinds of datasets. Okay, and you can download them manually by clicking this download zip function button, or you can also click on this raw button that will give the data in the text format and you can download them. So for today's lecture, I have taken these two data frame, which gives the population of some countries from 1960 to 2023. So we'll use this data frame. Then we also have a data frame where the air quality index of some cities were recorded. So, and we will not download this data frame in our disk. Rather, we will see how we can download them using Julia itself. Okay. So let us begin. Let us go to the full screen mode and annotate the notebook. So we will see how we can download web pages using Julia. So let me copy the URL. Let me quickly see if the URL is copied. No, it has not been copied. So just wait a moment. I will copy the URL of this first data frame, of this first data set where the population of the countries are listed. So I have copied the URL. Let's go here and go to full screen mode. So in order to access our website, you can use this HTTP package. Remember, we downloaded it at the first cell. We installed this package here. So you can use this HTTP package and this .get method. So this is a method or function that has been defined within the HTTP package. You can write it like this, http.get, and within quotes, you can pass the link and that will download that web page. So this web page is nothing but tabulated data. So here you are getting the whole response from the HTTP package. It is saying that this is the version of the package, this is the status code. Again, we are not doing a web scraping course, so we will not look at those things. So this is, you can see our data. So you can get the body of any web page. In this case, there is no web page. This is just a CSV file. You can get that with the dot body parameter. Okay. So this has many parameters, this HTTP GET response, and the dot body parameter will hold the body of the web page. In this case, this will be the data. So we can call it population data. Okay, let us save it so that we are not downloading it over and over again. Now, we knew that this data was stored in a comma separated value format or CSV format. So we will use this CSV package to load this data. So we want to read the data. So we will use the csv.read command and we'll pass the data. If you run, you will get an error. This will say that the population is not defined. Sorry, that was not the error that was trying to show. So if you pass the correct variable where the data is stored, you will still get an error. And this is telling that provide a valid string argument like data frames. Okay, so it has already suggested that you should use data frames. So the problem here is that it is reading the data, but it does not know which kind of object to use to store the data as a variable and show it to you. So we are gonna use the data frame. Okay, so it will take some time to read everything and load it in a data frame. Let us wait a couple of moments. And you can see that the data is loaded perfectly. You can check by visiting the GitHub page whether these are correct or not. I will not do that because I know that this is correct. So what we will do is we will store this in a data frame variable. So let us call it population df. Now you can see that the column names here also have spaces. So we can simply use this command that we talked about a little bit ago and pass it the population df data frame, and that will remove all the spaces from the column names. So this will be much easier to work with. So now let me check again. You can see no spaces. We can delete that. So let's plot this data. Since we are directly plotting from a data frame, we can use the df at the df macro. We can pass it the data frame, which is population underscore df. Then use the plot function. We want to plot this year and value. So this value is the population, and this year is where the population was recorded. And this is done for all countries, almost all countries, I think. So we want to plot year and value. And you will see that you will get a plot. This is taking some time because you can see this data frame is quite large. This has 16,930 rows and 4 columns. So again, you can use the size function on data frame objects also. So the nice thing that here you can do is group this plot using the group keyword argument, and you can say that I want to group them using the country code or country name. So I want all of these plots to be separated for different countries. Okay, so we are going to group them by country name. So if you plot them again, you will see this is your plot. We cannot see anything. So let me increase the size. Let's make it 1,000 by 1,000 plot. And you can see this is our plot. Okay, here this is probably too big. Okay, so for now, the legend is blocking. We can remove it, and this is our plot. So you can see this is the total. This is something else, IDA, IBRDA. I don't know what that is. So these are classes also. And here you will see East Asia, then South Asia, and on there you will also see China, India, those, and these are smaller countries. Okay. So what this data set does is that it will also accumulate all the data based on continuous and those things. So you can probably see that when you have someone else's data, it is not always easy to work with. So the next thing that we're going to learn is how to process data. So we'll use this data frame that we have created, population underscore df, and we will only look at data that is relevant to us, and that is called data processing. So that will be the next part of this video. Okay, so let us see how we can process this data. So we'll be using another package here. That is, so we'll be using the query package to process our data here. So this is the package, and you will see that this is a package for querying Julia data sources. It can filter, it can project, join, sort, group data from any iterable data source. And it works on data frames also. So let us see how we can use this to sort our data. So the first thing that the query package, so the first thing the query package provides is this drop NA macro. What this will do is if your data have missing values, it will filter those out. So let us see how we can use it, and we will also get to know about the preferred syntax of using this query package. So we are supposed to use it with this pipe and then angular bracket symbol. So you write the name of your data frame, then you write a pipe symbol followed by a angular bracket. That is signifying that we are passing this data frame to the next macro. and we want to check if we have a missing values in this data frame. So that we can do using the drop in macro. Then it has after it has checked all those things, we will create a data frame again. And if we run it, you will see that the size is same. So our data didn't have any missing values. But still, this is a good function. You will see another example later. I will show you where the data has some missing values and we can filter them out using this one macro. Now, let us say we want to filter out the population per year of India only. Okay. So how can we do that? We will again use the above syntax. We will write the name of the data frame, then we will pass it to a macro, and this time we will use the filter macro. So the filter macro will look at the country name column. So here this underscore is actually referring to each of the object of this data frame. So this type symbol is passing this data frame to this macro, and here we are just saying that we want to look at this country name column of the data frame. Okay, so what we want to check whether this is equal to India. Then we can again create another data frame after our filtering is done. And this is wrong. Let us do that, and you will see I have mistyped country again. So now that you have done it, we can see that our data frame is now giving the values for only India. So we can save this, say on another data frame, say population DF in India, and we can use the DF macro to plot it. So let's do a normal line plot, and we'll be plotting the year versus this value, which is the population. And let me give it a color of red, or maybe purple. So we will see that our data is plotted. We can again turn off the legend. So this is our data. It has been plotted against year. The x-axis is year, and this is the population. Similarly, we can do a scatter plot here, and that will show all the points. We can specify the marker size to be a bit smaller, and we have our plot. Now, suppose we don't want to do this plot only for India, but we also want to look at the population of USA. So we can do one thing. We can save this, and we can save this in a variable, say plot India, and we can repeat this process. And now we will look at United States of America's population, and Let me rename it. Probably the name is different. Okay. So you can see that it is unable to find this country name. Probably it is saying something different. So we can look at the country code, and that should be USA. And okay, so it was just United States. So this is our data, and we can again use the df macro to plot it, but this time we'll use the plot exclamation function, and we will explicitly tell that we want to plot on this axis, which is defined in this variable plot India. So again, we will pass the year, the value. Let me copy these settings also. Let the color be green. There is an extra comma, and let us plot it. And you will see that both of them are plotted. Now, you can do this for all of these countries separately, but again, in coding, we don't want to repeat ourselves. So we can use the filter function, sorry, the filter macro, and we can get all the data that we want filtered from this parent data table. Let us see how we can do that. So let me call it population EF interesting. And now I want to check the same filter, but let us look at the country code, that will be easier. And we can specify it like this. We can use the pipe symbol and say we will look at India, USA, say Great Britain also, China, okay, and that will be IND. And this will be another data frame, and you will see that this is showing everything, but you cannot see all of the country name differently. So there is another thing that you can do. You have a nice unique function available in Julia. You can pass. So let me do it gradually. So we want to look at this, and we want to get the country name variable, and you will get this array that contains all these values from the first column, and then we can pass it to a function called unique, and that will only show you the unique values. So this is China, UK, India, USA. So that's the four country that I wanted to look at. Okay. So now let me again plot it. So we will generate a new plot, and let's see how the plot looks like. Okay, you can see that everything here is plotted using the same color, but we don't need to worry about that because we know we can specify colors like this. And what is the error? The space shouldn't be there, and this should have, okay. So the earlier case was correct, I think. No. Okay, so we can do one thing. We can just define the color palette. Let's say we want to use tab 10. So now you will see that even if we change the color palette, everything is using the same colors, because here what this is essentially doing is this population df interesting dot er, it is getting this array and this array, and this is just plotting these two arrays. And since this is scatter plot, we cannot properly see, but if we make it a line plot, you will see, if we type it correctly, you will see that this data is connected like this. So that's not what we wanted, right? We wanted to plot them separately. So let us again plot it in scatter. And this is happening because this 1960 data will get repeated for China, India, USA, like for all the countries. Okay. So what we can do is our data frame has already defined those datas differently with two different IDs. One is country code and one is country name. So we can use those to say that we can use those to indicate to the plotting this DF macro that these are all four different data sets and I want to plot them in different colors. So let's see how we can do that. We can copy and we can specify the group. So this will group the plots by looking at the country code. Okay. So now if we plot it, you will see that everything is being plotted in different colors. We will also see that the legend is being shown here. Okay. So that's one nice trick that you can use when you are plotting directly from a data frame. So let me show you another thing. The query.jl package is very powerful. You don't have to specify all these conditions like this. What you can just do, let me delete all these things. Okay. And probably we should create a array also. So you want to look at IND, then I think BNG will be Bangladesh, then China, USA, GVR. Okay, we want to look at all these countries. So what we can just say is that to check whether the country code of our each row of our data belongs to this array. So this array is interesting countries, and here equal symbol, we can replace it with the belongs to symbol, and you will see I have missed a parenthesis here, and this will not also be there, and We are using variables. If we fix that, we have not run this. Okay, so now this is doing something, and we can check whether this is equal, and you will see that both the data frames are same. So you can, okay. So now suppose other than filtering this, we also want to manipulate this data. So here these values are all in all too large. So what we can do is we can represent them in terms of millions. Okay. So let us see how we can do that. Let us start from that command, and here when you are writing too many macros with this pi symbol, you also have the option to write them on the next line. You just have to do it after the pipe and arrow symbol. Okay. So here we have filtered our data. Now let's say we want to divide everything here by 1 million. How can you do that? There is a function, sorry, again, there is a macro called mutate, and this will take your column name, and you have to specify how you want to change it. So we are dividing everything by million. So yeah. Another thing that you can do, you can, after mutating and filtering the data, you can directly pass it to the df macro. So here we'll say that we want to plot, and since, let's see this comment here, after df, at the rate df, we were passing the variable that was in the data frame, but since we are passing the data frame itself, we don't need to mention the name of the variable. Okay, and we can also remove that variable definition. So again, we want to plot er, and value, we want to group them by country code. And now let's do a line plot and specify the palette also. So let's run this. Okay, so this has to be like this. So it only takes the name, and you can see that here our plot is much nicer to look at. So let us use the tab 10 palette, and you can see all the Y data are now in millions. Okay, so we can also put labels here. A title also. And I have a couple of typos. Let me fix them. We can also specify the font sizes. And okay, let me put the legend on the top left. Yeah. So here, this is our plot. We can do another thing. Since the data is distributed in a large range along the y-axis, we can also say that our scale along y-axis will be log scale. So it has to be log 10. And you can see that the plot looks much nicer now. Okay. So that's how you can use these query.jl macros to process data stored in your data frame. Okay. I will just show you another command, then we'll move on to the next section. So let's say if we run this, then we will get all the columns that was originally in the data frame. Suppose we don't want this country code command column because these are all representing same thing. So what you can do is you can use another macro called map, and within curly braces you can specify the columns that you want. And again, we have to give this pipe operation. Okay, so that here is set. This is again we are just specifying that from each row choose these values and map them in a data frame. So let us run it, and you will see that the country code is now called. So let us again plot it. And since we have removed the country code, we want to group them by country name now. And you can see this is our plot. So just we'll make it a scatter plot and change the marker size to 2 so that it looks nicer. This will work if you spell scatter correctly. So this is our data. So you can see how powerful this data frame library and this query.jl package is. Together with the plots.jl package, they can do pretty nice things with a data frame. Okay, so let us just see one more thing, then we'll move on to the next data frame that I want to discuss, and there we will just show some application of these macros, and then we'll move on to the next section. So let's move this here. So this legend column is not supported by Plotly. So let us just move to the GR backend now. So I just wanted to use Plotly to show you that it is very interactive. You can zoom into a location right in your plot object. You can do zoom in, zoom out, You can auto scale it, you can pan. So these things are possible. Okay. So now let's move to GR for the next section. And you can see that is this is working. So let us just change the font size also. Yeah, now it fits. So this is our data. We will not have any interactivity here, but you can clearly see that this is the card for China, this is for India, this is for UK, and this is for United States. So with that, let us see another data set, and we will just go over these functions one more time, just so that you can get a good practice. So this will again be downloaded from GitHub. So this is the link, and this is the dataset for air quality index of some cities. Okay, so let us read it. So we will use again the csv.read command. Then in HTTP, we will get the web page in this URL. Then we will pass the body of it, and we want to read it in a data frame. So let's call it AQYDF. So let's run it. It's gonna take some time to download the web page, and you can see this is our dataset. So now on the very first line, you will see that some are labeled missing. So we do not have data there. Here also one value is missing. So we can use the drop in macro and just remove this rows which has missing data from our data frame. So here it has 45,000 rows. So let's rerun it and see how many rows it will have. So almost 1,000 rows were there where some data were missing. So this is our data set. Again, we can see that some columns, which are the names of the city here, have space in between them. So what we can do is use this command, just copy and paste it, and we just have to change the name of the data frame. So you can see here the spaces have been removed. Now let's work with this data. So here the first column is representing date time. So we can check it, and you will see that this is date and time when the data was collected, and this is written in strings. So if we just plot it like this, we'll use a scatter plot. and let's say we plot the date time and the air quality index of Vancouver. So you will see that there is some nice repeating pattern in the dataset, but we cannot see what's in the x-axis at all. So we can try to rotate the label by 90 degrees, but then also it is not looking very nice. So what you can do is Julia has a dates package also. So this library will uh, help us to parse dates in different formats. So this is a standard library. That means it comes pre-installed with the Julia version that you're installing, and you don't have to add this package. So to use it, we just have to say using dates, and see, you don't need to download it. So now what we want to do is, suppose this is our date. If we check the type, this is a string object. We want to convert it to a date object, and this will allow us to also use the greater than or less than comparison with dates. So let us see one thing, that if we pass within this date function 2015 as a string, this will give us the date of 1st January 2015, and we can also check the type of it, and we see that this is a date. Okay, so we can also specify the month and date, and that will be incorporated accordingly. So what will happen if we pass this? You will get an error because it knows this format, but it doesn't know how this time is written here. So we can understand, but we have to specify to the dates package, so to the dates function, that how to parse this time also. So what you can do is you can give it this date format keyword argument, and there we can specify that the first is y. So we can specify in what format our date is given. So this is year, month, day, then with a space we have the hour, minute, second. So you can learn about all these symbols and what they mean by going through the documentation of the date package. So you can read through the documentation here. You can see that this is how date format is used. So I will not go through all the options. So if we run it, you will have another error. This should be a date format. Okay. So now you can see that our date has been parsed nicely. So we can save it in a variable, say date. We can see the date here. So what we can do is we can use this operation on the whole column. So before doing that, we can see the comparison operation. So let's ask if this date is greater than 2015. That means if this is after 2015, you will see this is false. If you ask if this is after 1997, you will see that this is true. So this is working very nicely. Okay, so let's apply this function to the whole column. How can you do that? We have already seen how to use query.jl. So let us get started. We have already seen how query.jl works. So we'll pass the data frame, we'll drop the missing values, then we are going to mutate, and finally we are going to export as a data frame. Okay, so what we are going to mutate? We are going to mutate this. So this is date time, and that will be using this function, and instead of this string, we will pass the elements of each row in this datetime column. So let us run it. And so mutate will not have these curly braces. So this is working. So let us do another thing. Suppose we don't want all these cities. We only want the data of the first 4 cities. There's a 5. So we can do that. We can take the date column and then we can choose these columns. Okay, and let us use this pipe symbol also, and you can see that it now has only these 5 cities. So let us use another filter also. So we can do that here. So let's say we don't want to print all the data from 2012 to 2015. We want the data after that. So we can do that easily. So we can just specify that we will take all the data after 2015, means after 31st December 2015. And this will do the checking operation. So let us complete this, and you will see that we have lost most of the rows, and the data starts from 2016 now. So let us save this in a different data frame. and let us use the plot function to plot that data. Okay, so we will plot wait time, and that will be the same x parameter, and after that we are going to plot all the columns. So okay, so let us see the plot. So these are all the values. So let me just change some attributes so that we can see them clearly. Okay, so this is our plot. So with this also we have seen how we can use all of these packages nicely together and plot our data frame with simple macros. So the last thing that we might want to do is to save our data, and we can do that using the csv.write function. So it takes two positional arguments. First will be the name of the file that it's going to save, and then we should take the data frame that we want to save. So if we do it, we will see that it has been saved. How to check it? We can just open the file which we have saved, and we want to load it in a data frame. So you can see that these and these are exactly same. So we can also check that. You will see that this is true. So this is actually saving the data and loading and checking that this has saved it correctly. Okay. So with that, I think we have discussed a lot about data frames. Now I want to tackle a few things that I wanted to discuss about plotting. So the first thing is how to do animations. Why do we need this? Because they look very fascinating. So if you are solving a problem, if you are doing this kind of data visualization, that is extremely good. But if you have the opportunity to show animated videos, that's even better. So Julia Plots.jl package has the capability of doing animation. And since today we have used macros mostly, we'll also be using a macro to do animation. So animation can be done using the dot animate macro or also the dot gif macro. Okay, so let us see how we can do this. So what we're going to do is we will plot a sine function. Okay, So let's do it between begin and end block, and let x be from 0 to 4 pi in the interval of zero point 0.5, and our y will be sine of x. So if we just plot them, they will look like this. You can make it a scatter plot, and these will be the points. So what we want to do is we want to animate it in such a way that all the points will be starting from here and then growing along this curve, and ultimately we'll be getting this plot. So what we are essentially trying to do is generate frames like this. So let me fix the x limit to 0 to say -1 to 13. So we want to generate a plot like this. Then on the next iteration, we want to generate something like this. Then we want to generate something like this. Then so here I am increasing them in more than one steps. So in our animation, we will like each of the point to appear in one of the frames. So we can do it by using a for loop and plotting them individually, and then saving all the frames using a external software into a video. But so we don't want to give this much effort for just making an animation, because the plots.jl package has already done it for us. So how can we do it? We can use the animate macro, and it takes for loop. So this will run up to the length of x, and let me save it in a variable called any. And what will it do? This will just do a plot of x and y, and it will plot those variables. So we can specify some other details. So let us run it, and you will see that this is showing animation objects, and we can view it using the GIF macro and passing the animation object. Okay, so let me make it a scatter plot. So you will see that this is not plotting like we wanted to. So what is the catch? This is happening because we have defined our for loop wrongly. We wanted to do it like this. So in the first frame, we wanted the I to have value 2, so that it is actually plotting at least 2 points. So now let us do it, and you will see that this is our animation. But again, this is not looking very good because the axis limits are changing dynamically with the plot. So what we can do is we can fix the limits, say -1 to 13, and y will be -1.5 to 1.5. So if we rerun, we will see the animation happening. So one can also plot a line on top of this. What you can do is just do another plot, and let me change its color to be something like very green. Typo, and you can see that it is being plotted. So two things that I wanted to discuss. I will just save this code and reuse it. So let me change the variable names. Let me actually delete the second part, and let us call it any1, and this will be also any1. So let me run it again, and this is the animation that you obtained previously. So what will happen if we increase the number of points? Two things will be there, and somewhere I have forgotten to use, yeah, here. So this was also supposed to be x1. So two things will happen. The animation will be a lot smoother, and it will take more time to generate. So what this animate macro is doing is that this is plotting every frame and saving them in memory. Okay. So when you want your animation to be smooth, it will definitely take up more time. So here it took 15 seconds to generate this animation. In the give function, we can also specify FPS, say 30. Then let us wait. The animation will get generated again. So you see that nothing is changing because 30 was the default frames per second. So FPS means frames per second. So if we check the length of x1, so we total have this many frames because the animate macro is running this for loop. So we have this many frames, 252, and if we increase the frames per second, our FPS value to be 50, that means our animation will show 50 frames in a second, and to show all the frames, it will require around 5 seconds. So let us rerun it, and you will see that the animation is a lot faster. So you can control the speed of the animation, not the speed of execution of generating this frame. So we can control that, control the speed of the animation using this FPS attribute. Okay, so now that this was one example, let us look at another example. So let me quickly rename the variables. I think this is the last one. So if we run it, but I want to show some thing here. So previously we run it like this. So let me just make this 0.2 so that the code executes a bit faster. And this is our animation now. So see that we have used the plot function here. What will happen if we use the plot exclamation function? Let us run it. And you will see that it is becoming this legend is getting generated and everything is getting plotted on top of each other. So this function basically means that it will take the last plot and it will plot everything on top of that plot. So you have to make sure that you are using the right version of this plot function when you are doing these animations. Okay, so we will end today's class by solving the problem of a projectile motion, and we'll also animate it. So let us again do it quickly. This is our begin and end block. Suppose our velocity is 10. Suppose the angle is 30 degrees, so that will be 5 by 6. So what will be the time of flight? That will be 2v sine theta by g. We have to define the gravitational constant. This will be 9.81. So what we want to do is we want to see the projectile getting thrown. Suppose this is a ball, so we want to see the ball getting thrown from the start point, and we want to see the movement of the ball with time. So what we can do is generate an array of time. We can use the range function. So 0 to stop, and the stop value will be time of flight, and we want 100 points. Okay, so now we want to plot the position of the ball at each point of time. So how can we get that? Very easy. We know the equation of motion for projectile. So let it be called proj x, the x value that will be 2v cos theta times time. So this will be a element-wise operation. Similarly, the y coordinates will be 2v sine theta times time minus half gt square. So this is our time. So we can do one thing. We don't have to write the dot everywhere. We can just use the @dot macro. So let us run it. So this will give us the trajectory. So let us check if this is correct. This was projectile. Yeah. So you can see that this is a projectile, but this is not ending. I must have written something wrong. So let me quickly check it. Okay, so this is happening because I have written this formula incorrectly. This will be v cos theta times time, and this will be v sine theta minus half ct square. So now if we rerun it, you will see that our projectile is going up and coming down, but what we want is a animation. So Let us do it. We will save this in an three variable. Let us call the animate macro. Again, we will use the dummy variable I to loop over the data points. So this will start from 1 and go on till the length of time. Let's end our for block and let me just write what we want to plot. So what we want to plot is so let us fix the limits also. And let us see if this will run. So I'll give a heads up that this will throw an error, and this is happening because if we look, let me comment it out. If we look at the thing that we are plotting here, that is just a number. Okay. So the I is a dummy index. It will take these values 1, 2, 3 up to 100 because our length of the array is 100. So, but when you are indexing it like this is just giving a single number. So this will not work. Plot function doesn't know how to plot a single number. So what you can do is plot 2 points. Okay. So let us do that. So let's start from 2 and this will be I minus 1 to I, and let's run it. And this is saying the min and max function. So okay, I made a mistake here. This is minimum and maximum. So it's running, I think. So it will take some time. Okay. So we see that this is our projectile motion. So let me also add a reference to the ground. So you can use this command axh line to plot a horizontal line, and we will plot it at 0 and make the line with 2, and the color will be brown. So let's redo our plot. And what is error? So let us change this to 10 so that the animations are happening faster. Okay, so I think the correct function is just h line. So let me see. Okay, this is running now, and this will get a tuple. So you can see that this is our line. So here this 2 is too much. I think we can make it around 0.5, maybe even smaller, 0.25. So this is now looking good. Now let us increase the number of points. We can turn off the legend, and we can also specify the title to be time. So the time will be time I. We will convert it to a string. And it is saying no method exists because this is string. And you can see that the time is increasing. It is starting, it is going down at the top, then it is coming at the bottom. So since we are plotting more than one ball, what we can do is we can plot sort of a trail. So we can do that by plotting, say, 5 data points. So this will start from 5. This will be I minus 5 to I. So let us run it. And sorry, this should be 6. You can see it is plotting 5 points. So if you want to make it a trail, what you can do is change the marker size and alpha. So just we'll do the marker size for now. So we want the first point, the leading point, to have the larger size. So I will do 1:5. That means the first here, the first point will have smaller size, then it will have marker size 2, 3, and then 4. So we have repeated this keyword argument. That's why it's showing an error. Let me remove and rerun it. So it's working almost like what we thought. The problem is this is plotting 6 points, and now you will see that this is looking much nicer. The last thing that we can do is spread things a bit. We can specify that. So you can see that this is plotting a connecting line also. We don't want that. So you can say that this is a scatter plot only, and we can change the opacity of the markers like this. So the leading point will be completely opaque, and the last point will still have some opacity. So say 0.25. We can generate 6 points like this. Now let us rerun it. Now you can see how nice the animation looks. Okay, so with that, let us conclude today's lecture. There are many things that you can do with this animation object. So I will give you some problem probably in the next class to solve using animations. So for today's class, let us end here. Okay, so before closing the video, I just want to make sure that this animation looks nice. So I will do some changes and close today's lecture. So